Hi everyone, it's Mrs. Griffin with the Unit 5 Lesson 10 Part 2 video. We're going to be talking in this video about more similarity transformations, which combine rigid motions with dilations. I'm going to show you two ways to do each problem. I'm going to start off with the construction tools, and then I will go back over how you can use the TRRD method. So, with construction tools, some of you may find this a little bit easier because you're actually creating what you say you're going to create. So if you're going to do that, you work backwards from the TRRD method, and we're going to do DRRT, dirt. And so the first thing we're going to do is dilate. So we're going to start by picking a center to dilate from. And I'm going to choose point D just because this is giving me more room below the original shape. So if D is my center of dilation, it's going to remain fixed, and I'm going to extend past each of the other points, like so. And then, because the scale factor is just names of sides, what I'm going to do instead of trying to figure out how many times to make things bigger or smaller, is I'm going to use my compass just to measure them. So I'm going to measure between D and E. So I'm going to put the point of my compass on D, and I'm going to open it so that it goes to E. Now figure out how big is this shape supposed to be. And then remember, once you measure something, you swing the arc to show you did it. And then I'm just going to repeat that onto the other figure. So I'm going to go from D to E again and create E prime. And that's where I will put E prime. Then I'm going to open from D to A, triple prime, and measure that and repeat that measurement over here. And that will be A prime. Then we're going to do the same thing from D to B prime, measure that. And just like earlier, we're going to bring over from point D along the segment to get to B prime, and that'll be B prime. And then lastly, we'll do the same thing to measure from D to C prime, triple prime, and then we will swing it around and bring it over to point D, and then copy out where C prime should be right here. And then if we connect all these together, we will get the new hexagon or pentagon like this. And so then we've dilated it. Now if we check our orientation, we can see whether or not there's a reflection or a rotation. And we're going to do the reflection first if there is one. So if I look at the orientation, A, B, C, D, E, I'm going in a clockwise direction. And on this one over here, A, B prime, C prime, D prime, E prime, I'm going counterclockwise. So there is a reflection. So I'm going to pick one of these sides to reflect this shape over. I'm going to choose one of the ones that's connected to point D because that way these lines are more accurate. And I'm going to choose CD. So that way I have more space over up and to the right. Now since DC is the line I'm moving, D and C are going to remain fixed, and I am going to measure how far E prime, A prime, and B prime are away from each one of those. So E prime is this far away from point D, and if I swing that around in one direction, I'll get this arc. And then I'm going to see how far away it is from point C. So I'm going to move my compass to point C, or C prime, either one, they are collinear, so it's up to us. And I'm going to see how far away point E is from that one. And I'm going to do the same thing. I'm going to swing my arc around. And where it crosses on this side is going to be my new E. So this point right here will be E double prime. Next, I'm going to reflect point A prime over. So I'm going to measure how far away point A prime is from point D. And I'm going to swing that around to the other side. And then I'm going to measure how far it is away from C as well, just like I did with D. And once I get that measurement, I'll swing that one over too. And then where they cross on the other side is where A double prime goes. And remember, this is basically like rotating at 180 degrees around both of them. And so this here will be your A prime, double prime. Next, we'll do the same thing with B. So we're going to measure from D to B to A prime and swing that one around to the other side. And then the same idea, we're going to also measure it from C and swing that around to the other side too. And where it crosses over here, this will be our B double prime. And then we can connect each one back to D and C, the new C, the one that's been moved, and you will get this pentagon, which should be the same size as the other one. I'm a little bit off, but close. And then finally we are going to do our capital R, which is to rotate. So we're going to do a rotation around a center of rotation point P so that A prime double, B double prime, C double prime, etc. maps to the triple primes. So we have to find the center of rotation between this third pentagon and the last one. So what I'm going to do is I'm going to use the points that I know are most accurate. I'm going to use D and C prime, and I'm going to find the center of rotation for each one. So I'm going to go more than halfway between D and D double prime, rather D triple prime. And so I am going to swing an arc for that amount, and then I'm going to flip it around and go to D triple prime and swing that same arc, and that'll create a perpendicular bisector when I connect them. Then I'm going to do a second one. I'm going to use C prime and C triple prime because those I know are more accurate. So I'm going to do the same thing. I'm going to open more than halfway between them, and I'm going to swing the two arcs to create a perpendicular bisector between C prime and C triple prime. And then I'm going to connect those to make the perpendicular bisector as well. And the point where they meet will be the center of rotation, which we will call point P. That's why I'm calling it P, because that's how I had it named down here. And this is a sequence of rigid motions and dilations that maps one onto the other. Now, some of you will prefer constructing because it will be easier. Others will want to stick to the original method. That requires sketches, and it requires that you make sure to be very specific about what you're doing. So I will show you that as well. If we're going to use the TRRD method, we start with a translate. We translate the little shape to the big one so that one of the corners locks with the other. So I'm going to choose E to E prime, and I'm going to show how I can slide this one over. And you would just make a sketch, not a construction, of this one, and then label them all with single primes. And you would have this. The next thing you would want to do is capital R, rotate. So we would want to rotate this little shape so that one of the sides locks on top of one of the other sides, meaning we are starting to share a side. And so if we were to rotate around that point E triple prime using the angle that is going to map A prime to A triple prime's line, this angle here, then we would have our shapes lined up so that they're sharing a side. And so you could see how D prime would move to D double prime, C prime to C double prime, B prime to B double prime, A prime to A double prime, and then E would still remain fixed. So it all turned so that this side landed on top of one of the other sides. Next would be the lowercase r, which is a reflection. So we're going to reflect over that side we just landed on top of. So we're going to reflect over A triple prime, E triple prime. And so I would reflect over this line, so it would land over here. So B prime would land over here, and B triple prime. Now doing that means I should add another prime over here and make this last one 4. And then A prime would flip from here. Or it would actually be still on the line that it was on. C prime would flip from this position over here to this position. And again, since I'm adding triple prime when there was already a triple prime, I'm going to tack on another prime in that spot. Okay, and then D prime is here. It would flip to this position, and the same thing, I would tack on another prime here. I'd be left with this one inside here, and then I could just do the dilation last. So I'm going to dilate it centered at E triple prime, and then the scale factor is any side you want from the final image over any side you want from that matching side from the image, the pre-image. Okay. On to number 19. So similarly, we can do TRRD or construction tools. If we're going to use construction tools, we do TRRD backwards. So first we're going to do the dilation centered at whatever one you want. I'm going to choose B. By scale factor, A triple prime B prime, triple prime over AB. So I'm going to measure how much it takes to get from point B to point A on my final, because basically all I want to do is make it the same size. And so I will measure how far out it is, and remember that you always make the mark when you measure it. And then you're going to repeat that to find where A really belongs now. And you're going to do the same thing with point C. Measure from point B to point C, and do the arc to show you did it. And then repeat that over here so that you'll find out where C prime belongs, and you have made the triangle smaller. Next, we'll check orientation. ABC is counterclockwise, ABC is clockwise, so we do have to do a reflection. I'm going to pick BC because I want to pick a line that uses the same center as before. So I'm going to flip point A over BC. Since B and C are both on that line, they're going to remain fixed, and I don't have to actually do any work with them. So I'm going to measure from B to A, and I'm going to swing that around to the other side. And the same thing from C. And I'm going to swing that around, and where they connect, when I make this a little bigger, they will connect, I will get point A prime. And then I will get my new triangle, which has been reflected. And then finally I have to do the rotation. So I'm going to construct the center of rotation. I'm going to use the ones I know are the most accurate, which will be B and C prime, to construct my center of rotation. So I'm going to go more than halfway between B prime and B triple prime. And then I'm going to do the same thing over here and construct the perpendicular bisector. And then I'll do the same thing between C prime and C triple prime and construct that perpendicular bisector. And where the two bisectors meet, it'll be the center. And then I'll call that one point P or something like that to be my center of rotation. And then your angle can pick a pre-image point through P to its image point, or you can say you're mapping. Also, you can do this one using TRRD2, using just a sketch. So the first thing you do in TRRD is you translate. So we're going to take this triangle ABC and we're going to translate it so that one of the corners locks up. I'm choosing A, which will map over to A prime like this. When you go to sketch that, it might be a little challenging, so you might want to choose to map vertex B to B triple prime instead. I think I'm going to adjust this to make that true. So we're going to use B to B triple prime instead. Okay, and make it here. Then we're going to rotate it around B triple prime, and this time the angle I'll pick is A triple prime, B double prime, and then go back to A. So I'm just changing that to ABA instead, because that way this triangle will turn and AB will lock up like this. Then I can flip it over A triple prime, B triple prime, and it would land here. And then we could dilate it centered at B triple prime, so that it would go closer, and then it would land right here on this end triangle. Alright, you're going to pick the way you like best. I will talk to you in class tomorrow.